Aldehydes and ketones. Aldehyde is an organic compound containing the CSO functional group at the end of the hydrocarbon chain. Methanol, ethanol, pentanol. A ketone is a compound containing the CO functional group, bridge between the two hydrocarbons or any class of organic compounds characterized by a carbonyl group attached to the carbon atoms. Ketone, propanone, acetophenone, benzophenone. Carbonyl compounds, aldehydes and ketones are collectively known as carbonyl compounds due to consisting of similar types of CO carbonyl group. Aldehydes are more reactive than ketones due to presence of CS bond which can be broken easily than carbon-carbon bond is ketone, aldehyde, ketone. Structure of carbonyl compounds, formation of sigma bond, pi bond, geometry of carbonyl group. In the formation of double bond between the oxygen and carbon, one of the sp2 hybrid orbital of carbon atom overlaps with the p orbital of the oxygen atom, resulting formation of strong sigma bond. The structure obtained in trigonal planar with the bond angle 120. The carbon atom still contains one p orbital which undergoes sideways overlapping with p orbital of the oxygen atom, resulting in the formation of weak pi bond. Hence, the double bond between carbon and oxygen atoms consists of one sigma bond and one pi bond. Preparation of aldehydes and ketones from the alkene ozonolysis. Alkene is reacted to ozone and formed ozonoid, and hydrolysis produce carbonyl compounds. Ozonolysis of 1-pentene to lower aldehydes. From gem dihalides, 1,1-dichloroethane produces ethanol. Source of aldehydes in ketones, bitter almonds and aldehydes, camphors, benzaldehyde, camphor, progesterone, testosterone, camphor, progesterone, testosterone, muscone structure. Nomenclature of aliphatic and aromatic carbonyl compounds, IPC name of aldehydes, prefix plus word root, primary suffix plus secondary suffix L, methanol, ethanol, pentanol, 2-chloro, butanol, 2-methyl-butanol, cyclohexane, carbaldehyde, 3-methyl, cyclohexane, carbaldehyde. IPC name of ketone, prefix plus word root, primary suffix plus secondary suffix to 1, propanone, acetophenone, benzophenone, 2-pentanone, 3-methyl, 2-butanone, 3-hexanone. Synthesis of aldehydes and ketones, preparation of aldehydes, oxidation of primary alcohols. Primary alcohols can be oxidized to either aldehydes or carboxylic acid depending on the reaction condition. In the case of the formation of carboxylic acid, the alcohol is first oxidized to aldehyde, which is then oxidized further to the acid. By reduction of acid chlorides, the mechanism of acid chloride reduction of aldehydes to lithium aluminum butoxides. Mechanism, the aluminum, this carbon, lithium, and this electron transfer to this carbon and transfer oxygen and negative charge. Raymond-Tymon reaction. The Raymond-Tymon reaction is chemical reaction used for the autoformylation of phenol, with the simplest example being the conversion of phenol to the salicylaldehyde. The reaction was discovered by Carl Reimer and Frederick Tiemann. The Reimer equation was Carl Reimer, not the less known Carl Friedrich Reimer. Phenol chloroform. When chloroform deprotonate by the strong base to form the chloroform carbanion, which is quickly alpha eliminate to give dichlorobenzene. This is the principal reactive species. The hydroxide will also deprotonate the phenol to keep the negatively charged phenoxide. The negative charge is delocalized into the aromatic ring, making it far more nucleophilic. Nucleophilic attack of the dichlorocarbene gives an intermediate dichloromethyl substitute phenol. After basic hydrolysis, the desired product is formed. Preparation of ketones, oxidation of secondary alcohols. Secondary alcohols are oxidized in the presence of potassium permanganate or potassium dichromate to produce ketone. By Fragile craft acylation, acid chlorides are treated with benzene in the presence of anhydrous aluminum trichloride to produce aromatic ketones. Physical properties of aldehydes in ketones. Formaldehyde is colorless gas with irritating smell, and acetaldehyde is volatile liquid at room temperature, but ketones are colorless liquid with sweet smell. Melting and boiling point carbonyl compounds are higher than that of the corresponding alkenes, but lower than the corresponding alcohols due to dipolar nature of carbonyl group. Reaction of aldehydes and ketones, ketoenol tautomerism. Ketoenol tautomerism refers to a chemical equilibrium between ketone or aldehyde and enol alcohol. The ketone and enol forms are said to be tautomers of each other. Nucleophilic addition reaction. The carbonyl group of aldehydes and ketones contains carbon atoms with partial positive charge and oxygen with partial negative charge. Nucleophilic attacks on positively charged carbon atom to form the intermediate, which also combine with proton to produce addition product. Acid catalyzed nucleophilic addition reaction. Carbonyl compound is deprotonated by acid, which is attacked by nucleophile to give the addition product. Acid catalyzed nucleophilic addition. The general mechanism of this reaction consists of three steps, not two, but the product result because hydrogen and nucleophile across the carbonyl pi bond. This mechanism protonation process nucleophilic attack. Base catalyzed nucleophilic reaction, addition of hydrogen cyanide. Aldehydes and ketones undergo reaction with hydrogen cyanide to produce cyanohydrines. The reaction progresses very slowly to be using pure hydrogen cyanide. Hence, base as the catalyst helps to speed up the reaction. This is because catalysis helps in the generation of cyanide, which acts as a stronger nucleophile and adds to carbonyl compounds to produce the corresponding cyanohydrine. Cyanohydrines are important synthetic intermediates. Mechanism of reaction due to the electronegativity difference in the carbon atoms and the oxygen atom. The carbon-oxygen bond demonstrate a polar behavior. This is turn results in gaining of the partial negative charge on the oxygen atom and partial positive charge on the carbon atom. The partial positive charge of the carbon atom will attract cyanide ion of hydrogen cyanide. The double bond of carbon-oxygen will break and the new carbon cyanide bond development occurs. Furthermore, the unstable oxygen will attract the hydrogen ion from hydrogen cyanide. Addition of ammonia and derivatives. Many nucleophiles like ammonia and derivatives ammonia can also be added to the carbonyl group of aldehydes and ketones. The reaction of ammonia and its derivatives is reversible, and the reaction happens in the presence of acid to form addition products. The reaction equilibrium will help the product formation of because the fast dehydration of the intermediate complex. Thus, the reaction finally forms the compounds carbon, nitrogen, Z. The structure can be alkyl Z is OH, aryl, amine, etc. Reaction with primary amines to form imines, addition of ammonia and aldehydes, addition of alcohols, addition Aldehydes undergo reaction with the monohydric alcohol to produce aminoacids or alkoxy alcohol intermediate. The aminoacid will further undergo reaction with an alcohol to produce same dialkoxy compounds or acetals. The reaction is carried out in the presence of dihydrogen chloride. On application of similar conditions, ketone undergoes reaction with ethylene glycol to produce cyclic compounds or ethylene glycol ketones. The dry hydrogen chloride present in the reaction protonates the oxygen atoms present in the carbonyl structure, thereby increasing the electrophilicity of the carbonyl carbon. Thus, it helps in the nucleophilic attack of the ethylene glycol. Further hydrolysis of acetals and ketones with mineral acids will help to retrieval of respective aldehydes and ketones. Addition of Grignard reagent. Grignard reagent or RMGs demonstrate polar nature. In this compound, the carbon atom is electronegative in nature and the magnesium atom is electropositive in nature. The polar nature of Grignard reagent helps the compounds react with aldehydes and ketones to produce additional products. The additional products undergo decomposition reaction to give alcohol, water, and dilute sulfuric acid. Planning of Grignard synthesis. In the planning of Grignard synthesis, Grignard's reagent carbonyl compound determines the synthesis of alcohol. All of the reagents should be chosen which is readily available. For example, 2-methyl-hexanol, we have to start from bromobutane. Limitation of Grignard synthesis. Grignard synthesis are useful nucleophiles, but they are very strong base. It is strong possible to prefer the Grignard reagent from a compound that contains any hydrogen more acidic than hydrogen atoms of alkane or alkene. Solvent should be dried, that is free from alcohol, and apparatus also should be dried. We should be careful in the preparation of magnesium halide, that is presence of carboxylic amine cyanide group in dead benzene. Ring contains acidic hydrogen that can decompose the Grignard reagent, so any part containing these groups should be avoided. Aldol condensation reaction. Base catalyzed condensation of alpha hydrogen containing two similar or dissimilar aldehyde reaction is known as aldol condensation reaction. General aldol condensation reaction. One of the common example of base catalyzed aldol condensation is stated below, in which catalyst generally used in hydroxide ion. Mechanism of aldol condensation. Cross-aldol condensation, when different aldehydes and ketones are used in condensation reaction, is called cross or mixed aldol condensation reaction. Uses of aldol condensation in synthesis. The aldol condensation is very useful in the preparation of large molecules from simple starting materials. In biosynthesis, when large molecules are produced, condensation reaction provides the only reasonable rules, since all the starting materials are small molecules containing 2 or 3 carbons. Aldol condensation is useful for lengthening the carbon chain. It is used in the lab preparation of alcohol, dehydration of alcohol products. Aldol products are strongly heated or treated with dilute acid to lose water molecules alpha beta unsaturated compound. Wittig reaction. When the carbonyl compounds with aldehyde or ketones are treated with triphenyl phosphonium alkylides, phosphorus allyls to produce olefin called Wittig reaction. Claisen condensation reaction. When alpha hydrogen containing esters are treated with the base sodium ethanoate or sodium methanol self-condensation to occur to produce alpha beta ketester, such type of condensation reaction is known as Claisen condensation reaction. Kinase reaction. When no alpha hydrogen containing or dissimilar type of aldehyde molecules are treated with strong base, self-oxidation reduction reaction occur by hydride transfer to give alcohol and sodium salt of the seed called kinase reaction. Wolff-Kishner reduction reaction. When aldehydes and ketones molecules are treated with hydrogen in the presence of strong base, reduction reaction occur to produce respective alkane. Clemenson reduction reaction: when aldehydes or ketones molecules are treated with zinc amalgam in the presence of conc acid, reduction reaction occurs to produce respective alkane is called as Clemenson reduction reaction. Analysis of aldehydes and ketones: 2,4-dinitrophenyl hydrogen test, sodium bisulfite test, Fallin test, Tolling test, sodium nitroprusside test. Spectroscopy is the study of absorption and emission of electromagnetic radiation between the matter and energy and depends upon the electromagnetic radiation. IR spectroscopy is the graph between the amount of absorption and emission infrared light against the frequency or wavelength of this light is called IR spectrum. IR spectroscopy: aldehydes and carbonyl stage carbon oxygen. Saturated aldehyde appears 740 to 720%. As ketones, if the exhaust aldehyde group are unsaturated and vibration is shifted to lower wave number. NMR. In case of NMR, also we can analyze the splitting of determine n+1. In case of NMR, the chemical shift the CS group downfield due to effect of adjacent aldehyde 2.4 ppm. The chemical shift of aldehyde hydrogen is 9.6. Splitting pattern n+1 rule. Mass spectra. Also, we can analyze from mass spectra. UV, aldehyde in ketones, 150 nanometer wavelength range. Simple aldehydes and ketones also have another much weaker absorption, higher wavelength, 260 to 90 nanometer. Okay, it's all about aldehydes and ketones under B.Sc. second year, Institute of Science and Technology, Tribhuvan University. And best of luck for your examination, and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.